We're going to continue talking about pure substances by looking in more details at compounds. Just a reminder, pure substances have consistent properties such as color, melting point, signified by MP, and boiling point, signified by BP. Compounds are made of two or more elements bonded together in an unchanging ratio. The chemical formulas of compounds will always have more than one capital letter. For example, glucose, otherwise known as blood sugar, has a formula of capital C, subscript 6, capital H, subscript 12, capital O, subscript 6. We see three capital letters in the formula, so we know there are three elements that comprise this compound. We also know that there are 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms in a molecule of glucose. This is what I mean by a constant ratio. Glucose will always have 6 to 12 to 6 carbon atoms to hydrogen atoms to oxygen atoms. Water is another compound that is made of hydrogen and oxygen. The formula tells us that there are 2 hydrogen atoms for each oxygen atom. Although the water that we use in our everyday life is not pure, we're going to assume that all of the water that we deal with in chemistry is pure. It's going to be important for you to be able to distinguish between compounds and elements. So I want you to stop the video and take a look at the information on the slide and determine whether each pure substance represents a compound or an element. Also determine whether each represents a molecule or an atom. Once you're done, restart the video. All right, so let's see what you got. We know that ethanol is a compound because we see the symbols for carbon, hydrogen, and oxygen in the formula. We also know that it is a molecule because there's more than one atom. There are 2 carbon atoms, a total of 6 hydrogen atoms, and 1 oxygen atom. Nitrogen has 1 capital letter, so we know it's an element, and because the formula has a subscript of 2, we know it's a molecule. Each molecule has 2 nitrogen atoms. The symbol of potassium listed has only 1 capital letter, so it's an element, and since there's no subscript, this represents an atom. An important thing to keep in mind is that compounds have different properties than the elements that comprise them. Let's take a look at copper 2 chloride, which is comprised of copper and chlorine. Copper is an element, number 29 on the periodic table. You've probably seen copper before, and you know that it is a metal with a sort of orange color that doesn't dissolve in water and, as a metal, conducts electricity. Chlorine is also an element, number 17 on the periodic table. Chlorine is a gas at room temperature, it is poisonous, and it is yellowish green. Copper 2 chloride is made of copper and chlorine, but this compound is completely different than the elements that make it up. Unlike chlorine, it is a solid at room temperature. Unlike both elements, it dissolves in water. And unlike both copper and chlorine, it's blue. There is no way, by looking at this compound, that we could figure out what elements comprise it. So, to sum up, elements are always found on the periodic table and have a symbol with 1 capital letter. Compounds have chemical formulas with more than 1 element, and I have to say it's not always easy to know if something is a compound or not. However, any chemical with a formula that has more than 1 element in it is definitely a compound. Furthermore, both elements and compounds are pure substances and thus have consistent composition and properties.